Alright, we are here today to discuss scientific notation. Scientific notation. Let me get my pen first because I always forget it. Here it is. Oh yeah, there's my pen. I'm going to use black, and then I'll use some other colors later on. But for the most part, scientific notation is simply put a way of representing big and small numbers because nothing is really, well, you'll see in a second. But scientists discovered that instead of having to write out a number that's ridiculously large, that sometimes it offends people, they spend a lot of time drawing zeros, and nobody wants to draw zeros all the time. What a pain in the butt. Well, scientists have realized by adding pretty much a simple two-digit number to the letters, I'm so smart, to 10 times power of something. Let's go ahead and say 3. We can save all of this space on our pieces of paper. The whole point is to use powers of 10. Now you may see some scientific notation later on that are negative exponents as well. But for the most part, we'll start one at a time. Let's go ahead and go to the next page. How to represent big numbers. Example. What you're going to want to do, and I'm going to use my my red pen for this so you can actually see what I'm doing. Look at that. Ooh, I can get like squiggly pens and all those other kind of stuff. We'll do green. Green stands out. Alright, so for the most part, I have the ability to take this number, which is already so flippin' long, and shorten it. I can shorten it and represent the same numeric value. So a big number, let's make it small. I'm going to go ahead, I'm going to start here. This is where the decimal point is. Although it's not really there, you can't see it that well. We represent this number like so. So, if I were to take this decimal and move it all the way right in between and right before I get to the last number, I could count the decimal places and figure out how this works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. Okay, let's write that in scientific notation. That would be 2.3 times 10 to the power of 12. Now you'll notice whenever you're using big numbers or you're shortening big numbers, your exponent will always be positive. Positive. Get it? Positive. So if I were to multiply 2.3 times 10 to the 12th, I would get this big gigantic number, also known as 2.3 trillion. We use exponents like this to help shorten and save space. Nobody wants to write out 12 zeros. That's a waste of time. Bunch of malarkey, if you ask me. So, how do we represent small numbers? Well, we do the same thing, but small numbers, they will have a negative exponent. So let's find out. I still want to move this decimal right here. I want to move it all the way right in between the last non-zero digit. Okay, I don't want to put it here, I want to put it right there. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal places. So I already know my exponent is going to be a negative 8. Negative 8 because that's how many spaces I moved back. Remember, this is a very small number. A very small number that's not even 1. It's not even a part of 1. It's so infinitesimal small, it's just ridiculous. So, make sure you understand that instead of doing what we did last time, we're going to use, well, let's use our 2.4 that we placed the decimal at. 2.4. Now, like always, we're going to use times 10 to the something power, but this time we used 8, but we went the other way. So we need to do times 10, like it's always 10, to the power of, you guessed it, negative 8. So, 2.4 times 10 to the negative 8 would be a correct representation of this number. Instead of drawing this all out, it's much wiser to just do what that is. Alright. What do you do with, let's say, a number that has a few straggler numbers like these guys right here? How do you incorporate them into the scientific notation? I hate to say it, but if we want to make sure that we do this correctly, we need to make sure that we really don't include them, because a difference of 120 is not going to make a difference when it comes to 2 billion. Okay? So we're going to do the same thing here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. 2.34 times 10 to the 9th. Notice how it is a positive exponent because it is a big number. If it was a small number, we'd be using negative exponents, but it's not. It's a big number. All right. Go ahead. I hope you've written down all of these examples. If not, go back and copy the examples that we've just done. And there they are again, just for future reference. Copy these down. There are 3 of them. And the last piece of information I need to give you is tonight's death metal reference is Job for a Cowboy. Yep, that's a real band. Job for a Cowboy. Go ahead and put it on your piece of paper. Turn it in tomorrow for easy 5 points.